Hello, virtual kids. So today we're going to be learning something new. So we're going to be learning something called distance and time line graphs. So we're actually going to be looking at different graphs and we're going to be talking about like how to read them. So if you look at these three right here, hopefully at the end of it, you can kind of tell me what's going on. Hopefully. All right, so what you're going to see on my screen is a little different because this is what I did to gave to my in-person kids. So yours is going to be a little different. So here's the first question I want to ask you. What is motion? So in your own words, what do you think motion is? So here's a simple scientific definition for motion. Motion is a change in movement or position of an object. So you probably put something about how motion is moving or movement going on, but it's also a change in position. So for example, I could say that my phone, which is right here on my desk, I could move it to another place on my desk. So motion could kind of be like you're moving an object from one place to another. So that's motion. So what we're going to learn about is how to graph motion. And we can use a distance time graph to show motion happening. All right, so here's our distance and time graph. So hopefully you learned in math kind of how to read a graph and kind of how to like plot points using ordered pairs. So you probably thought you were never going to use that ever again. Well, here we are. We're going to use it in science. So if you did good in math with that, this should be pretty easy for you. So let's see how well you paid attention to math. So time is always going to be on the bottom of the graph. So here's your question. What is this line right here called? Hopefully you said the line is called the x-axis. So if you got that right, maybe you'll get this next part right. So here's distance. So what's this line called? The y-axis. There you go. So time is always going to be on the x-axis and distance is always going to be on the y-axis. So remember that. All right, so here are a couple fill-in-the-blank notes that my kids did. So this says the higher the graph goes, the greater the distance. So as you go up this line, that means distance is increasing each time. And this fill-in-the-blank one says the more right the graph goes, the more time that is passing. So that means as you go down the time or the x-axis, that means time is like increasing also. All right, so here's another question for you. What is constant pace? So if I were to ask you to go at a constant pace, what do I mean? So constant pace means that you're not going faster, you're not going slower, you're actually going the same speed the whole entire time, which is something really hard to do. But if I were to tell you to walk at a constant pace, that means you're going to walk the same speed the whole time until I tell you to stop. So what we're going to do is we're going to make a distance time graph showing an object going at a constant pace. All right, so here's our graph. You've probably seen this before in math class. So let's see how well you paid attention. So the x-axis, what is our x-axis? Do you remember? And what is our y-axis? What did we label that? All right, so hopefully you said that the x-axis is time and the y-axis is distance. If you did, good job to you. So here's another question. So on time, we have this S right here. What do you think that stands for? So that S stands for seconds. So that means the x-axis is going up by seconds. So this could be like 1 second. This could be like 2 seconds, 3 seconds, and so on. So what do you think this M for distance means? So the M for distance means meters. So that means this is 1 meter, 2 meters, and so forth. So our distance and time graph is going by seconds that way and meters this way. So here is our scenario. So it says a dog runs 2 meters per second. So we're going to assume that the dog hasn't started running yet. So that means we're going to start at 0, and we'll say that's his dog house. So let's see. Here's another math question. So at 0, 0, that spot right here has a certain name. Do you remember what that is called in math class? So the point 0, 0 is called the origin. You're going to hear me say that a lot. So our first dot is going to be right there at the origin. That's where the dog began. So where would our next dot be after 1 second? So the dog is going at a constant pace, 2 meters per second. So what's like the ordered pair for the next dot? So here's where our next dot would be. So if the dog started here at 0, the origin, and if the dog ran 1 second, that means we would scoot over 1 second. So if it runs 2 meters per second, that means after 1 second, the dog went 2 meters. So that's where our next dot would be. So how far do you think the dog would run after 2 seconds? So if our dog ran at 1 second and went 2 meters, where do you think the dog would be after 2 seconds? And answer using ordered pairs. You should know what that is in math class. So after 2 seconds, our next point would be at 2, 4. So that means at 2 seconds, the dog ran 4 meters. So here's another question. How far does the dog run after 3 seconds? So where would our next ordered pair be if the dog ran 2 meters per second? So our next dot, our next ordered pair would be at 3, 6. So if the dog is running 2 meters per second, so at 1 second, the dog ran at 2 meters. So after another second, the dog ran 4 meters, and another second, the dog was at 6 meters. So the cool thing about a constant pace graph is that we could predict future movement. So since it's going at 2 meters per second every time, if I were to ask you at 4 seconds, where would the dog be distance-wise? What about 5 seconds? So that's the cool thing about constant pace graph. You can kind of do the math and figure it out. So I'm going to stop right here so you can kind of get that in your mind, and we'll begin with the next graph tomorrow.